Hey gang, welcome back. Welcome to the wild and wonderful world of chemistry, lecture number 50. Man, can you believe that? 50. Wow. We still got more to go. So this is chemistry part 8, and we're going to do some more moles for the masses. Okay? And that's you. You're the masses. I'm the asses. All right? Remember, 1 mole is Avogadro's number, capital N sub A, and it's 6.02 times 10 to the 23rd. Remember, in the last video, we talked about how absolutely humongous this number is, okay? And again, we're just going to be using 6 times 10 to the 23rd. I won't worry about this O2. Also, I'm just using a dark pen because people have mentioned that the red pen doesn't show up, so I apologize. I was trying to get a little artsy on you, but didn't work, so let's stick with this. Remember the molecular weight, chemists call it, or molecular mass. Remember, we used the periodic table and a mole, and we put things together, and let's review. Let's see what we're going to do, okay? So the first thing I want to do, as an example, is 5 moles of hydronium sulfate has what mass? Hydronium sulfate. So if we go back and remember our polyatomic ions, hydronium was H3O with a +1, right? Wants to give away an electron. Sulfate was SO4, right? With a -2 charge, wants 2 electrons. Okay? So we need two hydroniums for 1 sulfate. So the formula for hydronium sulfate is H3O2. And I can take the oxidation number away. So I need 2 hydroniums for 1 sulfate ion. Okay? So this is the formula for hydronium sulfate. Now we want to get the molecular mass. Now I want you to look. Notice the parenthesis. That means there's 2 times 3, 6 hydrogens, 2 oxygens, 1 sulfur, 4 oxygens. So 1 molecule of hydronium sulfate, 1 molecule has 6 hydrogen atoms, 2 plus 4, 6 oxygen atoms, and 1 sulfur atom. That's 1 molecule. Okay, so we're really interested in 5 moles, 5 Na of this molecule. Okay, so let's see what we get. So we have H3O2 SO4. So I need 2 times 3 is 6 times the mass of hydrogen, which is 1 in atomic mass units. Periodic table, everybody. Okay, plus 2 times the oxygen. I separated. So 2 oxygen was 16. Plus sulfur. Sulfur is approximately 32. Rounding off, it's fine. Okay, and then we have 4 more oxygens, each at 16 is 64. So we have a total of 6 plus 32 plus sulfur's 32 plus 64. So I get 134. So 1 mole of hydronium sulfate has a mass of 134 grams. Half a mole would have half of this, right? Would have 67 grams. 2 moles would have 268 grams. You just double it. But I want 5 moles. So what do? We multiply 134 grams per mole times 5. So here we go. So we calculated 134. So 1 mole has 134 grams. 5 moles is 5 times 134 grams, which is 670 grams. So 670 grams is the mass or molecular weight, if you're a chemist, of 5 moles of hydronium sulfate. Now here's another question I like to ask. So try to pay attention, and we'll do another example right after this. Okay, so watch. Suppose we wanted, I get to rub this off. Suppose we wanted the mass of 0.4 moles. Well, what do? Well, we take 0.4 moles times 134 grams per mole, and we get 53.6. So you first find the mass of 1 mole. And then you multiply by 5 moles, or 0.4, or 0.1, or 0.6, or 7, whatever you're asking. All right? It's not a big deal. But first, you must find the mass of 1 mole. Okay? But, of course, you need to understand how to put the formula together. Hydronium has a charge of +1, polyatomic, sulfate -2, and how to put these together. So that's the basic part. All right, now here's another thing I love to ask. All right, now in 0.4 moles of hydronium sulfate, how many H atoms are there? How many O atoms are there? How many sulfur atoms are there? Okay, so let's see. So in 0.4 moles, that just means you're multiplying by 0.4 Na, right? A mole is Na. of this, of the hydronium sulfate. What do we have? 0.4 for hydrogen, 0.4 Na times, remember, each molecule, there's 6 hydrogens, 2 times 3. So we have 0.4 Na times 6 is 2.4 Na. So how many hydrogen atoms are there? There's 0.4 times 6 is 2.4 Na, which is 2.4 times 6 times 10 to the 23rd. Remember what Na is. Okay. How many oxygen atoms are there? Well, in one molecule, we said there's 2 oxygens here, 4 oxygens here, for a total of 6 oxygens in one hydronium sulfate molecule. So we have 0.4 mole Na, 0.4 Na times 6. Again, 6, which is 2.4 Na. 2.4 times 6 times 10 to the 23rd oxygen atoms. So same number of oxygen atoms as there are hydrogen atoms. Okay? What's the next thing? Oh, let's do sulfur. So again, we have 0.4 of a mole is 0.4 Na times, how many sulfurs are there? There's just 1 sulfur in this molecule. So we have 0.4 Na times 1, which is just 0.4 Na, or 0.4 times 6 times 10 to the 23rd, or that would be 2.4 times 10 to the 23rd sulfur atoms in 0.4 moles of hydronium sulfate. That's a lot to say. Okay, so let's do another example because I know it's a bit confusing. All right, so stay with me. Let's see if we can do another example. And I think I've worked something out. Let's see what I said. Oh, ammonium phosphate. Ammonium phosphate. Okay, so let's look at ammonium phosphate. I want 0.2 moles of ammonium phosphate. Okay, ATE. If it was phosphide, it would just be the phosphorus. IDE is just the element. ATE is the polyatomic. So, I don't know if you remember, you have your notes. Let's look at ammonium. Ammonium, remember, was NH4, but that had a +1 charge, right? It wants to give 1 electron. Phosphate, what is phosphate? Is PO4 with a -3. So phosphate needs 3 electrons. Hydronium can only give 1, so we need 3 of these and 1 of these. 3 ammoniums, I'm sorry, for 1 phosphate. Okay, so I'm going to take all, since we have 1 phosphate, I can erase the parenthesis. I can take away the oxidation number. Can I take away this parenthesis? The answer is no. I can't take away the because the oxidation number, because I need 3 ammonium ions for 1 phosphate ions. Okay, so let's look at the mass. So we have 3 times nitrogen. If you look up nitrogen, I think it's 14, plus 3 times 4 is 12. 3, oops. So we have 12 hydrogens, but hydrogen has a mass of 1. Okay? Phosphorus is what? Is 31, I think. So if we round phosphorus off, has a mass of 31 atomic mass units. And you remember oxygen is 16. So we need 4 oxygens. So we have to add all these numbers together. And what do we get? Okay, what is that, 149? 149? Is that right? Is that what I wrote? I can't see. I can't read my writing. Okay, so I'm going to write 149. Let's do it together. Right, we have 12 plus, 3 times 14 is what? 42 plus 12 is what? 42 plus 12 is 54, and 31 is 85, and then we have 64, so we need to add 64. There's 9, 149. Okay, I'm right. Okay, so the mass of 1 mole of ammonium phosphate is 149 grams. And what do we have to do now? Well, I want 0.2 grams, moles. So I have to multiply 0.2 moles times 149 grams per mole, right? Now what does that give us? Multiply by 0.2. I think it's 29.8, right? Is that right? Yeah, 29.8. Two times 14 is 28. 2 times 9 is 1.8. So yeah, 29.8. So this is the mass of 0.2 moles of ammonium phosphate. Now, again, I'm going to ask the question. How many N atoms? How many H atoms? How many P atoms? How many O atoms? Okay, so this would be a test question. So let's see. In 2.2 moles, so we have 0.2 Na. So if we do nitrogen, nitrogen has there's 3 nitrogen atoms in each molecule. So I have to multiply by this by 3. So I get 0.6 Na N atoms. Now let's do hydrogen. Look, we have 4 hydrogens in ammonium. 3 times 4 is 12. So we have 0.2 Na, that's 0.2 moles, times, what did we just say? 12, right, times 1, right? So we have 12 hydrogen atoms, and that's equal to what? Is that 2.4? And that's what atoms? That was H atoms. That's good. That's not that bad. What else do we have? We have oxygen. So we have 0.2, phosphorus. 0.2 Na times, how many phosphorus atoms are in one molecule of ammonium phosphate? Well, it's just one phosphorus. So this is times 1. So we have 0.2 NaP atoms. See? Not bad. And then finally, oxygen. So we have 0.2 Na times what? Times 4, because we have 4 oxygens in each ammonium phosphate molecule. So we multiply this by 4, and we get 0.8 NaO atoms. And that's the answer. Unless, of course, we want to put the number in terms of the actual number of Avogadro's number. So this would be 0.8, for example, times 6 times 10 to the 23rd. And what's that equal to? Looks like it's equal to 4.8 times 10 to the 23rd oxygen atoms. That's good? Very good. Everybody see that? Let's do, I don't know what else to do. Let's do 0.6 moles of, let's do lithium permanganate. Oh, there's a tough one. Okay, so how many grams is that? Well, first we need the formula for lithium permanganate. Li is in group 1A, so this is a +1. Permanganate is MnO4, I believe, with a -1. So this gives an electron, this takes an electron. So we just need 1 lithium for 1 permanganate. So we don't need the parenthesis, and we don't need the oxidation numbers, okay? I do need a periodic table, however, because I just don't know this. Okay, so lithium, I think, is, what is that? It looks like 7. So if we look on the periodic table, this is closest to 7. Manganese, that's Mn, that's in group 7b, looks like 54.90. So I'm going to make this 55 plus 4 times 64. Oh, 4 times, oh, sorry, 16. I already did it. Okay, so 1 lithium, 1 manganese, and 4 oxygens. Okay, so what do we get? We get 62 plus 64, right? 62 plus 64 is 126. So 7 plus 55 is 62. 4 times 16 is 64. So we get 6, we get 126. 126 grams per mole. See, it's not bad. We want 0.6 moles. 0.6 moles equals 0.6 moles times 126 grams per mole. And we get, so we have to do the multiplication. 6 times 12 we know is 72, right? So this is going to be 72, and then that's 36, right? So it's 75.6. You check my math. Don't trust me, okay? So when I multiply 0.6 times, say 120, I get 72, and then 0.6 times 6 is 3.6, so 72 plus 3.6 should be this. Fantastic, okay? And now, once again, I would ask the question, how many Li atoms? Well, we have what? 0.6 moles Na times, remember we have one lithium in the lithium permanganate molecule, times 1 is just 0.6 Na Li atoms. Now we need the manganese atoms, Mn atoms. Once again, there's a 1 there, there's a 1, so it's 0.6 Na times 1 is 0.6 Na. And finally, if I say how many oxygen atoms, right? How many oxygen atoms are in 0.6 moles? Then I have O atoms, 0.6 Na times, now how many oxygen atoms are in a lithium permanganate molecule? There's 4 oxygens. So I need to multiply this by 4. It's not that bad, right? And that's equal to 2.4 Na. So that's how many lithium atoms there are, that's how many manganese atoms there are, and that's how many oxygen atoms there are in 0.6 moles of lithium permanganate. Once again, don't forget, this 2.4 Na, 2.4 Na is the same as 2.4 times 6 times 10 to the 23rd. What's that equal to? 2 times 12, 2 times 6 is 12. 0.4 times 6 is 2.4, so this should be 14.4 times 10 to the 23rd, which is the same as 1.44 times 10 to the, what? So I'm dividing this by 10, making it smaller, so I have to increase this by 1, make it 10 to the 24. This is the way the answer could be on an exam in terms of 10 to the 24th. 1.44 times 10 to the 24th. Okay, so there's a couple things happening here. Number one is you have to know how to write the formula for lithium permanganate. Right? Lithium group 1A permanganate is one of the polyatomics. So we found the formula to be this. Then we need to get the molecular mass, right? Or molecular weight. We look up lithium, we look up manganese, and we take 4 times the mass of oxygen, and that gives us 126 grams per mole. So if we want 0.6 moles, it's 0.6 moles times 126 grams per mole, and we said that's 75.6 grams. And then a question I love, how many atoms are in 0.6 moles? So how many lithium atoms? Well, there's 1 lithium, so it's 0.6 Na times 1. How many manganese? Not magnesium, manganese. It's different. Manganese atoms, well, it's 0.6 Na times 1. Again, 0.6 Na. Oxygen atoms, you can see there's 4. So we have 0.6 Na times 4 is 2.4 Na. But remember, Na is really 6 times 10 to the 23rd. So 4 times 0.6 Na is 2.4 Na, which is 2.4 times 6 times 10 to the 23rd, which is what Na is. 2.4 times 6 is 14.4 times 10 to the 23rd. And then this would be the way it would appear on a test. 1.44 times 10 to the 24th. Okay? So let's do one quick one again. Let's see if this will work. And let's see if the film cuts out. Sometimes the tape cuts out on us. Okay? Let's do 3 moles of, let's see, aluminum carbonate. Cool. All right, so we'll go quick. Aluminum's in group 3, has a charge of +3. Carbonate, CO3, needs 2 electrons. You remember how to combine these? You remember? It's like a common denominator. These are the oxidation numbers. If I take 2 aluminums and 3 of those, now this gives 6 electrons, and now this takes 6 electrons. So the correct formula for aluminum carbonate is, I'm going to erase the oxidation numbers, Al2 and then 3 carbonate atoms, ions, sorry. So let's get the mass of 1 mole. We need 2 times, what's the mass of aluminum? I don't know. Let me look it up. I have a periodic table. What's the mass of aluminum? Let's see. It's 27. Rounding it up. Plus, I need you to look. 3 times carbon, right? There's 3 carbons. Good? So it's plus 3 times 12 plus 3 oxygens, but 3 of those is plus 9 times the mass of oxygen, which was 16. So this is 54 plus 36 plus, what is that, 90, and 36 is 126, right? 54 plus that is 8, that's 90, plus that, so we get 90, add 90 to this, we get 6, what do we get? We get 1, 216. Again, check my math. Okay, so 1 mole has a mass of 216 grams per mole. All right, again, double check. Don't trust anybody. Okie doke. So 3 moles times 216 grams per mole. The moles go out, and I'm left with 3 times 216. 3 times 200 is 600. 3 times 16 is 48. So it's 648 gramskis. Da? Isn't that easy? Okay, so now again, I'll ask the question. How many Al atoms? Okay, so we have 3 Na times 2, because there's 2 aluminums in each molecule, equals 6 Na. What about C atoms? Well, how many C atoms? We said there's 3 carbon atoms. So we have 3 Na times 3. So it's 9 Na. It's good. Now we have how many oxygen atoms? 3 times 3 is 9. So O atoms, we have 3 Na times 9. Is that what I said? I said 9? Yeah. And that's equal to 27 Na. Okay, and once again, for Na, we can put in 6 times 10 to the 23rd. All right, so every problem is pretty much the same. I'll ask you what's the, how many grams, etc. Now, I want you to notice this. Suppose I say the opposite. Suppose I say 10 grams of NaOH, remember that? Hydrogen, sodium hydroxide. It's a drain cleaner, liquid plumber. It's a strong base, as we'll see. 10 grams of Na equals how many moles? You see, now we're going the other way. We're giving you the grams. You got to get. So first, again, we need the mass of 1 mole. So NaOH, 1 mole of NaOH. Well, Na is 23. Oxygen is 16, hydrogen is 1, so 40 grams in 1 mole. So 10 grams, so there's 40 grams per mole. So 10 grams is how many moles? Right? So we have 10 grams divided by 40 grams per mole. And what's that equal to? Well, it's 1 over 4. The grams go out, and that's equal to moles. If you write a fraction, 1/4 we can write as 0.25 moles. Okay? All right, let's do one more. Ha 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 ha.